All right, so good evening, everybody. Thank you for joining us for the second Wisconsin Databricks User Group meeting. My name's Ryan Shiva, and I'm a software engineer at Xorbix Technologies. So the topic of this meeting is the Databricks Data and AI Summit, which myself, Tom, our company CTO, and Asif all attended in June. It was an event held in San Francisco. It was 4 days long, and like Asif mentioned, it was totally packed with content. We heard a ton of really exciting developments and announcements from Databricks. We got to see demonstrations of how Databricks AI and data engineering tools are being used in the real world. And we met really talented data scientists and engineers, and also thought leaders from all around the world. And so there's so much continuously being added to Databricks. It's actually kind of hard to keep track of it all. So we wanted to get together and share some of the most exciting and really interesting things that we learned. But now I want to share my own experiences at the conference. Basically, what I learned by attending the breakout sessions, the deep dive sessions. So here's a brief outline of what I'm going to cover in the next hour. First, I'll give you an introduction to Retrieval Augmented Generation, or RAG. Yeah, so I'm just going to dive into what it is and how RAG apps can be implemented with Databricks. And after that, I want to show you it's a really awesome third-party tool called Llama Parse, and it helps you build RAG applications over more complex documents that might be difficult to parse with other tools. I really hope after this presentation, you're inspired about how you could use these new tools to innovate and solve problems on Databricks. First, I want to share some highlights from a breakout session I attended on RAG. It was by Databricks product team member Ina Koleva. So I want to first start with discussing a little bit the benefits and drawbacks of working with LLMs. You'll see how RAG can help you leverage your enterprise data. I'm going to define what RAG is, and I'm going to show you some tools for building RAG applications on Databricks. First, I want to give you an overview of how do LLMs actually work and what are they. So an LLM is really, it's a model and it's trained on a huge data set, hence the large in LLM. It could be the entire internet. It could be chat logs. It could be tweets, research papers, kind of like whatever you want it to be generating, you want to train it on that type of data. And one really awesome thing about an LLM is that it can actually give you a direct answer. Imagine you're typing something into Google, you get a list of search results, but you need to look through each result and see what's relevant, but an LLM can aggregate and give you one direct response. LLMs are also really good at generating text that sounds natural and human-like. And so it's very easy to comprehend the output of an LLM. One drawback of an LLM is that the model really only knows what it was trained on. And pre-training a model is very expensive. It could be millions of dollars, right? Tens of millions to train a large foundation model like GPT-4. If you need, such as you need the model to answer questions about things that have happened recently, an LLM might not perform well. And another thing to keep in mind is hallucination. So when a model hallucinates, it's basically when it generates a plausible sounding response, but it's actually not correct. And this could be a response that either it's directly contradicted by the data that it was actually trained on, or it could be that it's just making up facts and that was not in the training data one way or another. So it's not necessarily contradicting the training data, but it's still making something up. It might be true, it might not. Okay, so here's a little funny example of a hallucination. Imagine you're a user and you're using a chatbot and you ask it, what comes after thrice? And the chat responds, after thrice, the next term used to indicate numerical repetition is 4 times, which is correct, or quadrice. And it will tell you the sequence of repetition terms is once, twice, thrice, quadrice, quintrice, sextrice. Something seems wrong here. So you tell it, are you sure? Oxford Dictionary says you're wrong. And the chat tells you, you're correct, and I apologize for the confusion in my previous response. Those aren't English words, but the LLM made them up. So that's an example of hallucination. So something to keep in mind about hallucinations. So despite these challenges, LLMs can unlock a whole lot of business value if they're grounded in your enterprise data. Like I said before, LLMs might not be correct. They might lie to you. They might not be trained on up-to-date data. They might not provide a source, right? So the LLM is generating a response. It's not necessarily like reading a document and giving you citing a page from a particular source. It's just predicting the next token. So it could be trained on data. It could respond to you, with the, most likely, or it's doing like a search and it's returning the most likely response. But then you ask it, well, what's the source? How do you know that? And it'll just say, I'm not sure. I'm generating a response. I'm predicting the next most likely word based on my training. If the LLM is not trained directly on the data that is relevant to the questions you're asking, then it will not perform well. If you need to answer questions that is specifically based on your enterprise data and the LLM has not been trained on that, you're just using ChatGPT, obviously it cannot answer specific questions about your business unless those are already on the internet and within the training window when the model was actually trained. So at the bottom, there's just a little example. So say the user asks, what does DBRX stand for? And the model returns, I'm sorry for any confusion, but the acronym DBRX doesn't seem to have a universally accepted meaning. So the reason it doesn't know the answer is because DBRX was released after the model was trained. So pretty much we need to introduce a way to introduce enterprise data sources that the LLM needs as context to generate a correct answer. And the enterprise sources could be in various cloud platforms like Teams or in OneDrive or SharePoint, whatever. So the question is, how do we securely and reliably provide the context to the LLM? And so you've got two choices. You could either train the model further. In other words, you're fine tuning the model. You're taking an existing LLM and you're adjusting the weights. You're actually like tuning the model slightly based on some additional enterprise data. However, fine tuning is still pre-training. It's not as expensive as training a model from scratch, but it still could be a significant investment. So the other alternative is you could take the user question and you append it to the prompt. So an analogy for this would be fine tuning is kind of like studying for a test on a brand new topic. You're studying for chemistry and then you're going to be able to answer chemistry questions. That's kind of like fine tuning a model versus say an open notes test. So you've got like a little index card in front of you and it's got the information so you can just refer to that while you're taking the test, while you're answering the questions. That's kind of like appending the context with the question. You're giving the model the answer so that it knows what the correct answer is. So either you're making the model smarter, fine tuning, or you are giving it the answer. So here's an example of giving the model context to answer a user's question. So on the bottom, we've got, given the context information above, please answer the following question. So by the way, this is a prompt to an LLM. And then you give it the question. What was the purpose of constructing the Eiffel Tower? And how long did it take to build? And now at the top, what the user has pasted in there is a brief article, or actually an excerpt from an article on the Eiffel Tower. And that article actually contains the answer that you're asking. So the LLM is going to be much less likely to hallucinate, and it will be more likely to get the answer correct because you're giving it that information. Now I'm just going to briefly go over some requirements of what does this context need, what's the requirements for the context that you're giving the LLM to get accurate responses. So first, it needs to be real time. So because the user's question is real time, they might be asking about current events. They might want to know about current stocks or current real estate listings or whatever. So basically, you need to construct the prompt in real time because the prompt is based on the user's question, which is real time. Secondly, you need to provide relevant content, obviously. So the content must contain information that's needed to answer the user's question, or the LLM will not know what the answer is. And then third, for an enterprise use case, you want to extract this from your enterprise data, right? You are connecting your enterprise data, your organization's knowledge base, to the LLM, right? To supplement the prompt with relevant context. So now the question is, how do we do that? Step one, you could read this, it's like a little flow chart from left to right. So starting on the left, we've got our enterprise data. Now, this could be structured. It could be like text. And if you're lucky, it's just like text stored it in neat structured Delta tables in Databricks, for instance, because that's really what an LLM needs is structured data. Or more often, you've got some unstructured data. You've got PDF documents, right? Manuals, PowerPoints, etc. So you can imagine. So you take this enterprise data, which might be unstructured, and then you need to extract the content from the documents. So that's basically you're parsing the documents to get the text from the documents, which is what the LLM will be able to understand as text. After that, since these you could have like 500-page document, you could have 500 documents, right? So you need to chunk it into manageable size so that it can be provided to the LLM, not a whole 500 pages, but relevant chunks. So what you do is you chunk it. You could either chunk it like a page at a time, right? Or smaller chunks like a paragraph or two, or by sections or headings. Or you could even do like 1 or 2 sentences for a chunk. After you have chunked the text the next step is you want to convert the chunks into vectors, which are also called embeddings. Think of an embedding as it's a way to position a text chunk in a multidimensional vector space. You're taking that text and you're converting it to, you see here, it's a array of numbers. So that's a vector. And without going into too much detail, basically the vector store is going to position semantically similar chunks closer together. So you could see the little graph at the bottom. You could kind of imagine like similar embeddings, similar vectors are closer together in this vector space. What the LLM needs, all an LLM is just weights. It's just some series of numbers. And so what you need to do is convert the text into numbers, basically, into vectors. Back to the chart. So that you've got your vectors. You put these in like a vector database, for instance. And then, like I said, the chunks that are semantically similar, have very related meanings, will be similar in this vector space. And then after that, what you do is the user asks a question. You can see up at the top, the user is asking a question. And what you need to do is you actually need to take that text and you need to convert that into an embedding vector. And the reason you do that is so that you can perform a similarity search. You are going to take the question and you're going to look for what are the embeddings that are the most similar to the user's question, which was also converted to an embedding. And, say you might want to pull the top 5 or the top 10 results back. These are your chunks from your documents. These are the chunks that are the most semantically similar to the user's question. So they are likely to be the most pertinent, the most relevant to the user's question. So once you have found the the most similar embeddings, after that, you can decode these embeddings because we're converting these vectors back into text that an LLM can understand. And then once you've got these text chunks back, then you simply append the user's prompt and the relevant context. So now the LLM has got chunks, the most relevant chunks from your documents as context to be able to answer your question. And so now notice we didn't actually have to do any model training, any special model training. You could just use a foundation model that has been trained to understand human language. And now your enterprise data is being provided as context, similar to how, like, if you're typing in ChatGPT and you just paste a little article snippet and then you paste your question, it'll be able to understand it better. That's really kind of the concept of RAG, what we're doing. But we've got this retrieval process, which is a more sophisticated way of retrieving the relevant chunks. All right. So now this little flow chart is very similar, but I just want to go into a little bit more detail about like the vector search index. So the way this works is you start, you're down at the bottom, you've got your enterprise data, right? And you take the enterprise data and first, what do? You convert the text into chunks. And then once you've got the chunks, you would use the embedding model to convert the chunks to vector embeddings. And then once you've got your vector embeddings, you can create and then populate a vector search index. So once you've got your vector search index, which is really, think of this as like a database where you're storing all those vectors, right? And you will be able to, maybe it allows you to filter, apply filters to which vectors you're retrieving, and it will allow you to do this similarity search. And now up here, what you're doing is you are querying the vector index and you're finding the top similar context chunks. And then up here, you take the user question, you take the context that you retrieved, and you are appending them together into your prompt. And now see, this prompt will be passed to what's called the generation model. So now this LLM is being used. This is what you're actually giving the prompt to generate the output. And so here you could see at the right, this is your answer. So this is basically RAG architecture. I don't know if I covered that part, but yeah, you've got the user at the top left. They ask a question, it's fed to the same embeddings model, then you generate a vector embedding, then you pass it to the vector search index, and then that is what allows you to retrieve these embeddings, which will be used to supplement your prompt with context. So now that I've kind of given you an introduction to RAG, I just want to go over what are some advantages of RAG. Why would you like to use it? So first of all, RAG allows you to leverage your enterprise data, which lots of businesses, pretty much all businesses, want to leverage their own unique data. RAG will allow you to, instead of having to train your own model, and then it's out of date when you've got new data, and that's more recent than when the model was trained. Now you don't have to do that because you've got RAG. Models are less likely to hallucinate when they have the relevant information. If a model does not have information, hopefully it's not making things up, but it might make something up. Like if you ask it, what is DBRX? And it doesn't know what it is. Ideally, it's telling you, I don't know what that is. But if you are using RAG to provide the context, then hopefully that will happen far less. And you can build these systems to be really reliable. You don't have to modify a model, right? Like training, pre-training a model, even fine-tuning a model is a lot more technical versus RAG. It's very quick and easy relatively to get this up and running. And it's more computationally light because again, you're not like doing any training, which is very computationally intensive. It takes a lot of GPU power. This you're just passing a prompt to a model. And lastly, like I mentioned, you can ensure that your data is fresh. So like Databricks, it's got capabilities for streaming data or batch processing data into Databricks, which could then be stored in either a volume or a delta table. So as fresh as you want your data to be, this is how fresh it can be because it's being provided as context. It's being queried and then provided as context to the RAG pipeline. So now I just want to cover what I've kind of given you more of like a theoretical overview of how a RAG pipeline would look, but I want to show you, this is kind of the same graph you saw, but I've swapped out the embeddings and the vector search with the Databricks services. So you can see how is this accomplished on Databricks. For your enterprise data, the data would be stored in Databricks. And now this could be either in structured tables. A good format for that is Delta. That's the preferred format for tabular data on Databricks. Or it could be unstructured data like the PDFs, the PowerPoints, which can be stored in a volume. If you've got all your data as an iceberg, so you could use uniform and you can interact with your data, read and write to your data just as if it were Delta, right? It's kind of like treats it as one unified format, even though underlying it is iceberg instead of Delta. Like I was saying, so yeah, you want to take your enterprise data, which is hopefully stored in Databricks, and then you're converting it to text chunks, however you're parsing, however you're processing, you get it into text chunks. And what you would do is you would store that in a Delta table because LLMs want structured data, right? They want data with columns and rows in a tabular format. So that's what Delta does for you. So once you've got your text chunks, then the next step is you generate your embeddings. And so you'd use like a special model that's trained to generate these embeddings. And then once you've got your vector embeddings, you want to populate what's called a vector search index. So this could be like a vector library or vector database, and this is storing those vectors, that numerical representation of each of your text chunks. And the product, you can see kind of this outline here. The product that handles all this for you is Mosaic AI Vector Search. So this is a thing on Databricks, which it will handle model serving for you. It will allow you to quickly and easily spin up a model that you don't have to pre-train yourself. It will manage your vector search index for you and make that available to query. There's a lot of really good use cases, like an HR chatbot, for instance. Let's say you are trying to create an interactive, user-friendly way to learn about corporate policies. So you could create a RAG chatbot and you could train it on your own internal documents, which has all of your like HR policies. And then if an employee could interact with this chatbot, they go in and they ask like, what's the vacation policy, right? And this RAG chatbot would be able to use your documents as context. So instead of having a live person answer that question, you could have a chatbot do it. Just any kind of Q&A bot, that's a very good use case for RAG. Content and email generation, that's a good example. So like say you're a marketing team and you could be generating tweets, you could be generating emails, whatever. And you could feed in, like if you have like a marketing campaign, you see what posts perform the best, and then you feed that in as context to the LLM, and it can help you generate new marketing materials. All right, so we can move on to the next topic. And so what I want to tell you about next is this is a deep dive talk that I attended, and it was by Jerry Liu, and he is from a company called Llama Index, and he's talking about this brand new tool called Llama Parse. It will allow you to build advanced RAG over complex documents. And I'm specifically going to talk about their document parsing tool. So how are you taking these documents and you're getting text back out of unstructured data? So since I've already kind of introduced you to RAG, I'm going to show you a tool which it helps you improve your RAG applications, and it will improve the quality of the data that you're parsing. First, I want to talk about the goal of building a knowledge assistant. What are we setting out to achieve? And then cover a little bit like what are some ways that RAG can actually go wrong, and then show you a way that you can improve your RAG by improving your data quality. This concept of building a knowledge assistant, like what would you ideally want a knowledge assistant to be able to do? Well, basically, you have got a human which has a question, and you want the human to be able to ask the question. And to do that, you are going to query some sort of knowledge base, right? Think enterprise data, think your unstructured documents. And then you want to get back an answer. You might ask a very specific question, which has like it's a pointed question and it's got like a short answer about a very specific piece of data, which RAG is very good at doing that. Or you might have a more complex, nebulous question, and it could entail like a longer answer, right? And you might even have a question or a query that requires a lot of like task decomposition in order to be able to solve it. So like an example of this is like you want an LLM to generate an entire research report. That's probably going to be a little bit more involved than just asking a basic bit of trivia, right? Or another example I've seen is like you could actually set up an LLM chain to do some data science for you. So you might have a question and you want it to figure out what you're trying to predict. And then you might actually have the model piece together like a regression pipeline and query another model, depending on what you're prompting it to do. In the end, you might have a knowledge assistant and you are actually asking it to do like a lot of different sort of like types of tasks, right? Not just a simple Q&A. I'm just going to briefly cover how does RAG fit in to this concept or goal of building a knowledge system, which you've already seen the architecture in the previous slides. But here it is again. I'll just go over it briefly. You've got your retriever, which is kind of like taking your data, you're parsing it, you're indexing it, and then you want to retrieve relevant context. That's the concept of the retriever. And then you've got the generator. So this is your data querying. You are taking the retrieved context, you're combining it with the user's question, and you're generating a response. You could think of RAG kind of as like a new type of ETL on top of your unstructured data. In other words, your PDFs and your PowerPoints, right? So you're able to process and parse that data. And that's basically the first step to effective RAG. So I'm going to show you how LlamaParse, this third-party tool, can help you with that. So looking at our simple RAG pipeline, let's say that you want to parse some PDF documents. So you might be looking at like an open source tool like PyPDF, and you can definitely use that. And you could do like some sentence or paragraph splitting, and then you want to put it into a vector database. After that, you've got your retrieval. That top K is like you want to retrieve the top 5 most relevant chunks in your similarity search. After that, you're basically stuffing the context into this prompt, and then you're feeding the prompt into the LLM to get an output, which this is really nothing new. Okay, so I'm going to show you how can you improve your data quality, which will help you improve the performance of your RAG pipeline. So I just want to hammer this point home. Your RAG is really only going to be as good as the data that you're using. So how could we improve on this basic RAG approach? Well, one kind of common saying is like garbage in, garbage out. And by the way, this is not only true of LLMs, it's pretty much all machine learning models is the output of your model is going to depend on the quality of your data. So you really need the best data, the most cleansed, as good as you can to take your raw data and process it effectively into clean data. That will greatly improve your RAG's performance. So some things that could go wrong in the data processing step is, for example, like the relevant context you need might be missing. It might be messy. It might not be properly formatted in a way for the LLM to use it as context. So really, this data processing layer, this layer is going to be a very key part of improving your RAG performance. Again, a little bit of review, but basically the main components of your data processing layer are going to be parsing, chunking, and indexing. Parsing is where you're taking your PDFs or unstructured data and you're extracting the data. You're getting text out of it. Chunking is where you're transforming the data. You are breaking it into chunks that can be vectorized and then retrieved. Indexing is when you're putting it into your storage system. So indexing could be as simple as just you're generating embeddings and putting them into a vector index, or you might want to include some metadata with your vectors. So for instance, you might want to be able to, when your RAG is generating answers, have a source. So you could put the document title, you could put the page number as metadata and bundle that up with the embedding in your vector search index. I'm just going to go over some general principles for your data processing. So If you have a bad parser, then that can really affect your output. So your documents might have really badly formatted text or tables, and that will confuse even the best LLM. Even if you're using the most cutting edge GPT-5, if your document was not parsed correctly, it's not gonna answer the questions correctly. You could have bad chunking. If your chunks are too small, then it's kind of like what I was saying before. Like similar content might not be kept together. Like you might have related content on the same page, and if you're chunking it like for each like breaking it up into individual sentences, the LLM might not be retrieving all of that context that you need on the entire page. It's not retrieving all of the chunks. So then similar content would not be kept together. Let me give you an example. So you've got a PowerPoint, and in the PowerPoint, like the similar content, it's kind of on each slide, right? Like you're never going to have a sentence that's trailing off on one slide and then going to the next, or at least I hope you're not, or you probably need to make smaller slides, right? So then actually just chunking by page might be really effective for like a PowerPoint, right? Or if you've got like a PDF document, if it's separated by headings, you might want to really try to use these headings because otherwise the page, like the section might be scrolling to the next page. And if you're chunking by page, maybe you're like splitting context in half when you don't want to. These are like very important hyperparameters, your chunk size, how you're chunking, and then the overlap. And you just kind of need to experiment with it a little bit and figure out what is giving you the best output, and evaluating these things is really important. So I just wanted to tell you a little bit. A lot of documents could be classified as complex. You've got embedded tables, you could have charts, you could have images, right, in your documents. It could have different like irregular layouts. It could have headers and footers that is not parsing the same as like the text on the page. And then you could have text that's spatially laid out, and the spacing of the text is actually semantically important. So you could be losing information if you're just naively parsing a PDF into text and you don't take these things into account. So the naive RAG indexing pipelines will fail over these kinds of documents. And there's where you need a more advanced technique to deal with the complex formats. And again, this is what Llama Parse was created to address, is this problem. I apologize, this is kind of a small blurry image, but you could see on the left, just imagine, so you've got a PDF and it's got a table. And it's got like columns with headings, and then it's got values in these little cells. So here's an example of using PyPDF, that open source package for parsing documents, and it's trying to extract the info from this table. And now on the right, you'll just have to take my word for it because this is kind of small, but you've got like random numbers. The text is not, it's very disorganized. You've got like columns getting jumbled together. You are like cells shoved together. The columns are not preserved. Looking at this, you can't really tell what value belongs to what column. And so the LLM is going to have a lot of trouble with this. And now imagine you're taking this mess and you're chunking it. You might be splitting up columns, and you might be losing column headings. So it's not good. You're not going to have very good results from this parsing. And so I'll remind you guys that the more info you're losing, the more the LLM is likely to hallucinate, which is not good. So this is where Llama Parse comes in. Llama Parse is a special document parser, which is designed to let you build RAG over complex documents. And here's a picture of their code repo. Some of the capabilities are it's good at extracting tables and charts from your unstructured data. It can extract JSON. It can do image extraction. It's got support for tons of document types, PDFs, PowerPoints, Word, XML, even Excel. It came out just a few months ago, and it's had a lot of grassroots adoption. So it's quickly becoming popular. Okay, so let's see if I can show you guys some results. Let's talk through this real quick. So it's a company called Llama Index. I think they're based in San Francisco, and they're just kind of like a small startup. And they've got this one product that's really successful. So I'll try to use my cursor so you guys can follow along. So what Llama Parse did is they took some different PDF parsers. So you've got Llama Parse, PyPDF, PyMu PDF, Textract, and PDF Miner. And what they did is a little experiment. They took the Apple annual report for 2023, and you could see in this screenshot that Apple report has got a lot of data in tables. And what they did is for each parser, they built a RAG pipeline over the report. And then they asked the LLM a question on every cell. They asked, what was the net sales for products on September 30th, 2023? And then they're testing to see, is the answer correct or not, right? So green means that the LLM the RAG pipeline returned the correct result, and red means it was the incorrect result. You could see there's like one incorrect result here, and I think there's another one, but Llama Parse is doing a very good job of getting most of these answers correct, whereas some other parsers, there's a lot of red here. The LLM is not getting the correct answer for some of these values, which means like it kind of looks like for some of these, it's struggling to parse this last column for whatever reason. So this is not like a comprehensive benchmark by any means, but it's just an example. They said they use default settings for all the parsers. And so it kind of shows you, at least I want to demonstrate the document parser is very important. And obviously Llama Parse is showing this example because it makes their product look very good. So I'm going to show you more of like the architecture of the advanced indexing that Llama Parse is doing behind the scenes to parse these documents. So first of all, Llama Parse can work without this advanced indexing. It's still a good parser, but you're going to have the best results with your unstructured or complex documents if you combine Llama Parse with this advanced indexing. It'll help your RAG pipeline to be a lot more performant. So first, let's say you've got your PDF. This could be a PowerPoint, Excel document, whatever. So your unstructured data, and you use Llama Parse to parse the document, and you parse it into semi-structured Markdown. What this is it's got text, tables, and images represented in Markdown. And it also supports JSON mode, which can return outputs in JSON. So you could return the outputs in a variety of semi-structured formats. So once you've taken your PDF and you've parsed it into this semi-structured format, then you can extract the text, the table, and the image chunks. And the output of this will be a graph of documents. And each cell in the graph represents the outputs. These outputs could be, it's either a text chunk, it could be like a table, which you could store in like a SQL database, an image, for instance. So Llama Parse can recognize what are these different elements of your document. And Llama Parse represents each of these as a node. You can see the node corresponds to the individual object. So here it's like a text chunk. A node in Llama Index, it's basically it's an underlying object that's being indexed, and then you want to embed this. So you pass the nodes to, you could pass it to a multimodal model, and you can extract a summary of the object. And then what you're doing is you're embedding the summary. You're not embedding the object itself. So the way this could work with an image is you could pass it to a model that understands images and say, please summarize this image for me. And like, say it's a picture of a horse. And then it will say, this is a picture of a horse. And now what you're doing is you are generating an embedding for that summary. And then you save as metadata, you save a reference back to this image. The image can be stored separately. So when you go to your vector search index and you're retrieving embeddings, say that summary gets pulled back from the vector search. Now that summary has got the metadata, so you can retrieve that image back. And so this works for tables, text chunks, images, all these different elements of your document. So you can see this is a lot better than like PyPDF, which was just trying to brute force convert these tables into text. That didn't work very well. But I thought this was amazing when I saw it. So it's got like advanced table understanding. So like where a RAG would give you the wrong answer, Llama Parse is able to parse this table. That's a little example. Another fun example is like they gave it this comic book, which had apparently it had some LaTeX, which is a mathematical expression. And Llama Parse was able to take that LaTeX and extract the expression and keep the semantic context, whereas like a normal parser would just try to like read all these characters and it would be a big mess. So yeah, but I hope you check those guys out. They're doing some really cool stuff. All right, so that's a wrap.